안녕하세요. 아키텍처 팀의 김용욱 프로입니다. 오늘은 마이크로서비스 아키텍처에서 글로벌하게 대가이신 크리스 리처드슨님을 모시고서 마이크로서비스 아키텍처에 관련해서 여러 가지 이야기를 나눠보도록 하겠습니다. So, it is very nice to see you at SDS again.
Oh, I'm excited to be back.
Yeah.
Thanks for inviting me.
Yeah, I think the last time was you had a seminar here in 2018, I think.
Yes, like in the next door room, right?
Right. And I had a training from you in 2015, and you had seminars and various talks at that time too. Since then, you've been doing various work, and would you briefly introduce your work, and if there are any changes from that time?
Oh yeah, I mean, it's actually interesting to think about it. I feel like I've been focused on the microservice architecture for 10 years now.
Right.
Since 2013, though in the beginning it was not called microservices. Didn't really have a name. That sort of came, or it was 2012 actually. That came later. So yeah, after we met 2015 and then again in 2018, I've just been working with clients all around the world, helping them use microservices effectively. I guess one big change, of course, was when COVID happened. Yeah. Instead of traveling constantly, I just started sitting in my home office. And actually, for the first 6 months of COVID, things were really quiet. I feel like the world ground to a halt, but then everything just started being conducted by Zoom. But one of the things I did at that time was, it's like, oh my God, there's no in-person training anymore. So I created an online training course focused on the distributed data patterns of microservices. Yeah. So that was one direct consequence of the whole COVID thing.
Yeah, and I think you have one more training course which is called Workshop. I think I attended those two courses of you. Yeah.
So in a sense, what I'm doing these days in terms of training, yes, there's like a low-cost, online-only, I call it a boot camp, just to distinguish it from the workshops. And then there's two workshops. One of them is sort of a broad overview of the microservice architecture. So covering everything from what it is, how do you define it, inter-service communication patterns, distributed data patterns, deployment patterns, and so on. And then the other one, which is newer, I think I launched that last year, is focused on how do you define a microservice architecture. So in other words, here's a pile of requirements. What are my services? Their names, their responsibilities, their APIs, and their collaborations. And I'm super excited about that because I think that second workshop addresses the core problem that you have when using microservices is identifying them and defining them.
Yeah. As you know, I attended the second one, the more recent one.
Oh, yes.
And then asking you directly and you answer that, I think that was very valuable time. Yeah.
Good.
And besides the training, I heard you are having many consulting work too.
Yeah.
Did you have any chance to work with Korean companies? And do you see any Koreans like unique characteristics or any kind of issues?
Well, yeah. I mean, over the years, I've consulted with companies sort of all around the world, basically, but and more closer to Korea, Japan, China, and then also in Korea as well. I mean, it's interesting. I mean, I think you see this all over the world, but it's sort of varying degrees, right? And so you could say that, there's two types of software development. Well, one is sort of project-based development, where an organization will have a big project.
Right.
And they define the scope up front, and then they define, they pick when it will be delivered, and then they decide how much they're going to spend. And that is judged by how well it goes according to plan, right? And it's very sort of, in a sense, waterfall based, versus what I would argue is a more modern and more agile approach, which is basically, well, it's an agile, iterative, incremental style of development where you don't have big upfront requirements, and then you do things in a much more iterative fashion. And I think, in today's modern world, the latter approach is actually better. But I see two, especially I think more so in Korea, I see these big IT projects.
So does it, this kind of project-based development style affect when adopt microservices?
Yeah. The way I look at it, there's sort of three things that you need in order to deliver sort of modern applications. Because I think in today's world, sort of a key goal is to deliver software rapidly, frequently, reliably, and I could say sustainably as well. And to do that, you need what I call the success triangle, which is where you have three things. The first of which is DevOps, as defined by the DevOps handbook. And the reason I emphasize the DevOps handbook is that there's a lot of bad definitions of DevOps out there, right? In particular, there is no such thing as a DevOps engineer.
Right. You mean people say we adopted DevOps, but actually they adopt DevOps tooling. They just automated process, but not actual DevOps.
Exactly. Yeah, you have developers, you have operations, and then you have a DevOps team as well, right? That is not DevOps. I mean, DevOps, as defined by the DevOps handbook, is a set of principles and practices for delivering software rapidly, frequently, and reliably. So it's something that everybody does. It's not a tool, it's not a job title.
Right.
So it includes practices like either continuous delivery, which means that the software is always in a releasable state, and developers commit to trunk at least once per day. Their changes are built and tested by an automated deployment pipeline, and if the code passes the tests, it's releasable. And in a SaaS environment, you would deploy it into production at that point. So it's continuous deployment, not releasing once a week or once a month, but ideally many times a day. So that's the process part of the success triangle. The other part is the organizational structure, which instead of sort of typical organization is siloed. You have developers, you have QA, you have operations, and so on. Oh, security, right? And code or artifacts get handed off from one to the other, right? That's actually a very inefficient, wasteful way of getting work done. So the right way to do things is to have small, autonomous, cross-functional teams that are capable of, well, ideally discovering their own requirements, but at a minimum taking requirements and actually writing the code, testing it, and deploying it into production without having to hand off any of the work to anyone else. I mean, together those are actually very proven validated techniques for delivering software rapidly, frequently, reliably, and so on. And then you need an architecture to support that, which in some cases is the monolith, but if you're building a large application with a lot of people, it would be a microservice architecture.
Yeah, thank you for the explanation of the success triangle. In short, that means to be successful, it requires DevOps, continuous delivery process, and DevOps organization, autonomous organization, teams, and microservices. All three together makes it more effective.
Yes. So you don't necessarily need microservices. You actually need a loosely coupled, modular, testable, deployable architecture, which if you've got a small application, the monolith can be just fine. But typically for a larger more complex application with a lot of people, you need the microservice architecture. And then the last point I would make is it's not sufficient to actually adopt microservices without the other two things. The analogy I would for that is it's like buying a Ferrari and then pulling it around by a horse. Right? It makes no sense, right? You've got this high performance sports car, but you're going really, really slowly. And that's what happens if you have the microservice architecture without DevOps, without these small cross-functional teams. It sort of doesn't make sense, really. Well, except in a few particular situations, but generally speaking.
I think that is a very good point, but when I meet my customers or when I hear about Korean IT companies, like DevOps or process or organization thing is not that prevalent or not that widely adopted. There are many companies who actually adopted it like a DevOps toolings, but not DevOps process or continuous delivery. But they somehow they might need cloud migration or application modernization or microservices. So because my primary job is microservice consultant, my customer want me to help them to adopt microservices, but I find many companies not ready for process and organization. So in that case, it is kind of hard to explain them to you need to do something like that. But I think it might happen in other countries too.
Oh yeah, I feel like none of what we're talking about is specific to Korea, for sure.
Right.
Especially the misunderstanding around DevOps. I feel like that's everywhere. Even just like a few weeks ago, I saw an article in a very prominent magazine talking about how some company educated a lot of DevOps engineers, and it's like, no, there is no such thing as a DevOps engineer, right?
Right.
But so it's not unique to the career, but
Okay.
The other big point I would want to make is I think there's two views of IT, right? There's one view of IT is that it's just something we have to do, but we don't value it. It's just a cost, and we need to minimize it, right? And I think that's a very sort of old-fashioned view of IT. And then which was prevalent in the US as well for quite a long time, right? Where everything was outsourced because it's just not that important, right? But in reality, IT today is like central to businesses, right? Like if a company wants to launch a new product and service, it's extremely likely that there is some software behind that. And it doesn't really matter what industry you're in, whether it could be an airline, right? Particularly systems of engagement with customers, right? But even in mining and, oil drilling and so on, it's all about software. So software is actually kind of a strategic kind of capability of an organization. And you don't want to minimize, the goal shouldn't be to minimize the cost. The goal should be to maximize the capability, the software development capabilities. And there's even a study from McKinsey that basically shows that companies that are good at software make more money. And then also, if you think about, like, you're having problems convincing customers to sort of make the process and organizational changes. Well, first off, the McKinsey study says if you develop software well, and by that they basically mean DevOps and loosely coupled teams, you make more money, and that's a compelling argument, right?
That's
the
point.
And then the DevOps handbook, not the DevOps handbook, the Accelerate book, which is basically the research justifying why DevOps is a good idea, has found the same thing, right? There's like, you know, this is what high performance software delivery looks like, and companies that do this make more money.
Yeah. I think many people need to listen to you.
Yeah. Oh, and then I want to say one more thing. I find this fascinating, right? So you imagine, like, IT is done through these big projects, right? So in other words, software development, I mean, you have this maybe multi-month or multi-year project, and it happens from time to time, right? And then before you can do the project, you have to define the requirements, right? And then not only that, you kind of, because these projects don't happen often, you need to make sure that you have all requirements that you could possibly imagine, right? Because the next opportunity is not going to happen for another year or two, right? So you end up with these extra big projects or much larger projects as a result, with lots and lots of requirements. But the really funny thing is, there was this study from Microsoft that found that 1/3 of requirements were good, 1/3 of requirements were bad, and 1/3 of requirements made no difference. So literally, only 1/3 of your requirements are valuable. And then there were other studies showing that in enterprise software, there's just a whole lot of unused features, possibly half, right? So in other words, you know, maybe half of the development effort is actually going to, or more, is wasted on features that you don't actually need. And then the fact that these projects only happen periodically means that you want to have more features just in case, right?
Okay.
So so customers might think, oh, we're saving money by having these fixed price contracts, right? But in fact, they could actually be wasting money. Versus an agile approach, which is one that includes a lot of experimentation, right? So if you view a requirement as a hypothesis, namely, this is something we think the customer needs, but we're not sure, you could run some cheap experiments to validate the hypothesis before you actually invest a lot of money in sort of fully implementing that feature. So this sort of lean, agile approach can actually be cheaper.
I think people should listen to that,
It's basically being, let's just be agile, right? And you know, and I think, say, outsourcing IT to vendors complicates that, because you need a much more formal contract between the client and the vendor, more formal than between the business and the organization's own IT department, right? That's more, you got to meet this project by this deadline, but we can't sue you or anything. Whereas with between companies, it's much more legal. But in reality, there's no reason why you cannot have agile contracts, right? It's harder, I think, and maybe it means that it's sort of, you don't sign these massive deals, which are less exciting, but in reality, there's just so much evidence to show that this agile sort of iterative approach to development is superior to sort of the more traditional way.
You said that agile or incremental approach is superior to meet actual requirements or accomplish actual value. But I think that can be applied to when we implement microservices, because the fixed requirement and fixed period can be kind of big burden to adopt new technologies like cloud migration, splitting services into different runtime. So I think that when project team doesn't have any experience in defining, designing, implementing microservices, when they start project, it becomes big burden to them. So they want to hatch that. So one of the thinking every project think about is sharing databases each other, like because many people are good at writing SQLs and they know how to develop it, but when we split database, they need to find another way to implement it. So, but they cannot estimate how it's going to be hard or how long does it take. So they try to find another way to hatch that. And in many cases, sharing databases between service, many people think about that one. Like
yeah.
Yeah.
Well, it was certainly, I think, at least conceptually, it's easier to split code than it is to split the database. Especially because you sort of, as soon as you have multiple databases, you go from the world of ACID transactions to eventual consistency, which is conceptually harder and so on. But in reality, it's if you split the code, so you have a bunch of services accessing each other's database tables, you don't have microservices, right? You can claim that you do, but you do not have microservices. You basically have a distributed monolith at that point, which I would argue is worse. You know, it's the worst features of the monolith plus the worst features of the microservice architecture. Yeah, because if we go back to the definition of the microservice architecture, right? You know, it's an architectural style that structures the application as a set of services that are independently deployable, which means that you can build a service, test it, and when those tests pass, let me clarify. You can test it in isolation, right, independently of any other service, and when those tests pass, you can deploy it into production, which means no end-to-end testing, right? Which is another kind of conceptual obstacle that people have problems with. But if you've got a shared database where services are accessing one another's tables, you can't really test them independently because they are truly interconnected with one another. So you're not really benefiting from microservices, and you've just made things far more complex.
Right.
And you should just stick with a monolith.
Because it is very hard to convince in field, because people are so stressed. They are kind of worried about they might not meet their timeline, deadline, they might not be able to deliver their software in time. That could be very big contract breaking stuff.
Yeah, I mean, which itself is just a problem, right? Like, developers should not be stressed, right? Like happy developers write good code, stressed developers. So I think, yeah, like if people are stressed on the project, that is really unhealthy. And maybe that's an artifact of this deadline-driven development, right? Like if you think about agile development, I mean, you try to deliver things on time, but at the same time, you're recognizing that software development is complex and unpredictable, and therefore you can't really make guarantees about when things will be done, right? And then actually the other part is, let's imagine like, okay, we're doing a monolith to microservices migration. So the old way, well, the one option is to do a big bang rewrite. And the problem you have with that is that until it's done, you have not delivered anything of value, right? Whereas if you're doing it, what I would say is the better way is to use the strangler fig pattern, right? Which is where you're doing it in an iterative incremental fashion where you just migrate functionality out of the monolith into services in this incremental fashion. You are constantly delivering value. And I think the big bang rewrite could be stressful because you have nothing until you have everything. Whereas with the strangler pattern, let's say every sprint, right, you are delivering value. So in theory, the business should be happy, they're seeing things delivered, you're making progress. And to me, I think that eliminates a lot of the stress.
Yeah, you're right, and I think I agree. That is the recommended guideline when we migrate to system. But you shortly mentioned that reduce costing organization. Like when I meet my customers, their IT operation team is usually very tightened. They became kind of cost-effective organization, so they are always busy and they don't have many room to try something new. But when we do some incremental migration, operation team should get involved, because when we migrate one part, we develop one part of the system, all the other part need to cooperate together. So people from outside join them, but still the operation people need to do that.
Yeah, I mean, it's interesting. If you do a big bang rewrite, you basically forget about the old system, right? And then you just build a whole new system, and then you go, here it is. Whereas with the incremental approach, you are basically constantly modifying the old system to migrate functionality into the new system. So whoever's working on the old system is very much involved.
Right. So
but,
I think,
go on.
Yeah, companies which has very competent IT engineers, I think they can do that by themselves. But many other companies, they cannot.
Yeah, well, but the problem you have is, not only with the Big Bang rewrite is not only are you not delivering any value until the end, you're not actually validating any design decisions that you've made, right? Whereas with the iterative approach, after every, I'll just say sprint, right? Each sprint, you've got more functionality running as a microservice. It's running in production. It's being used, right? So you are validating that you have made some good design decisions, right? So that's fantastic feedback. So especially if you're new to microservices, you don't want to wait 2 years to find out that on day one, you made a bad decision and have been building upon that bad decision for a very long period of time, right? So this whole, I mean, it's interesting, a very important theme with sort of DevOps and Agile is like is fast feedback, like constantly getting feedback. Like literally, I write some code, I want some feedback on it, you know, within minutes, not 2 years later, right? And so the strangler pattern is giving you that feedback quite rapidly. So yeah, so there might be problems with an incremental iterative approach, but I would argue there are much bigger problems and much greater risks with the Big Bang rewrite.
Yeah, I agree with you. And I met a customer who has a big system operated by over 100 people, and when it requires to rebuild the system from scratch, which is very big money, and usually in that case it requires years to develop it, and so people already understand it that is very big project and very, very risky project. So I heard that they want to do incrementally, but to minimize risk, but it's too big system, so they didn't know how to.
Yeah. Well, I think the bigger the system, the bigger the cost, the more you should do things iteratively, right? Because it is so risky.
When you speak, when you talk about it before, like I think it was about microservices, I mean, about success triangle, you mentioned like process and continuous deliveries are required, but for a small system, microservices may not be required. For big system, microservices is required. You briefly mentioned something like that.
Yeah.
And can you say what would be the size, size of the system that need microservices, or like how many services needed for one system? Like I'm not saying not saying it is maybe having a hunch, just maybe it's not correct, but it can be a good guide.
I mean, a few things. I mean, because part of it is like, well, what are the goals, right? So, I mean, now might be worthwhile mentioning the dark energy, dark matter forces, right? So the dark energy forces are reasons to have services. And sort of the names come from astrophysics, right? So in astrophysics, there's dark energy, which is this anti-gravity that astrophysicists have created to explain why the expansion of the universe is accelerating. So it's actually, you can think of it as pushing matter apart, right? And I think that's a great metaphor for splitting into services. So sort of my view, by the way, of what a service, what a microservice architecture is that you have chunks of business functionality called subdomains. So sort of from domain-driven design term. And when you define a microservice architecture, you're actually trying to figure out how to group those subdomains to form services. So the dark energy forces are pushing the subdomains apart and putting them inside different services, whereas the dark matter forces, and that's another metaphor, right, which astrophysicists invented to explain certain observations, and it's like it's an invisible matter that has a gravitational effect. So it's pulling the subdomains together and encouraging you to put them together inside the same service. So there's a couple of dark energy forces that we could talk about, right? And one of them is team autonomy. So in other words, the more teams you have, if you have a monolith, the less autonomous they will be, because they're all contributing to the same code base and they're having to communicate, coordinate, which slows them down. So that's a reason to, when you've got lots of teams, to have multiple services. And I don't know what lots is. I don't know what the right number is. But you could certainly say if you only have one team, you don't have any problems of team autonomy, and therefore a monolith is good enough. Two teams, you know, and we're talking about teams of 5 to 9 people, right? 2 teams probably okay, but you know, then if it was say 10 teams, maybe you could get into problems with team autonomy. So that's one of the dark energy forces. The other one, which is good to talk about now, is fast deployment pipeline. Because another sort of key goal here is to have an automated deployment pipeline that can build, test, and begin deploying your application extremely quickly. And you could say within 15 minutes. Because if you take a step back, right, and let's imagine, so you've got, your organization is practicing continuous delivery. And what that means, or continuous deployment, what that means is at least once a day, each developer is actually committing changes, doing a git commit, git push to trunk. That triggers the deployment pipeline. And, you know, and so for every developer, you're triggering a build. And if that build takes a long time, your deployment pipeline will be a bottleneck, right? So let's just say the build is 15 minutes, right? And you've got 8-hour day. That means that you can do 4 builds an hour, 32 builds a day, right? I mean, it's approximate math.
Yeah.
So if you've just got, let's just say 20 developers, okay. But if you've got 100 developers, you know, and they're all committing every day, you know, once per day, 100 builds doesn't fit into an 8-hour workday, and the deployment pipeline will be this bottleneck. And so they're no longer getting fast feedback about their changes, right? Maybe at midnight they get feedback.
Oh yeah.
Right? So then that, you know, so then it's like, well, if we have a monolith, how fast can we make the build? And at some point, you can't make the build fast enough, which is why you could then use microservices, where each service has its own independent deployment pipeline, and different developers are committing to different repositories and triggering different deployment pipelines, and it has a much greater throughput. So that's another way of thinking about, well, how many services do we need, right? And the more developers you have, the more sort of scalable your deployment pipelines need to be, and the more deployment pipelines you need, which means the more services you need.
Okay. Thank you. And I think that introduces that, like, how elite or good IT organizations works. If your systems have 20 people to operate it or develop it, you don't need microservices.
Probably not. Well, I mean, so there's team autonomy and fast deployment pipeline. Those are sort of related to the number of developers, right? But there are other dark energy forces, one of which is multiple technology stacks, right? So if for some reason you need to use Java and Python, that would be a argument to have two services, right? And then the other dark energy force is segregate by differing characteristics. And this, which is sort of an umbrella category. But if you have subdomains with very different resource requirements, like one needs lots of memory and another needs lots of GPUs, you can scale in a much more cost-effective fashion if those subdomains are put in different services. So, yeah, because for instance, EC2 instance types with GPUs are like 8 times as expensive as general purpose machines, right? Or if you've got part of your application, some subdomains that are absolutely mission critical, and then others that are not, then you can improve the availability of your system and also reduce developer stress by deploying them separately. So like imagine you were processing credit card payments, right? And your business makes money by charging 30 cents per transaction. That's absolutely mission critical functionality that you would ideally have it as a separate code base, right? This is the API for authorizing, for charging credit cards. You have that as a separate code base, and ideally you're running it on separate infrastructure as well, like its own Kubernetes cluster with its own database. And then the rest of the system, which on the one hand obviously is important, but it's not mission critical, is running somewhere else. And they're loosely connected, they're loosely integrated through events, right? So that's yet another reason to sort of split up subdomains. And that could be, and that might be true of a really small system, quite possibly, right? And same with the scalability argument as well. That could just be one team in theory. Right? Especially if you think about, I think it was Instagram, right? They were maybe 10 people at one point.
But they just got exploded.
Massive, they're operating at massive scale. And so maybe segregating by resource requirements, perhaps, maybe that was valuable. I don't know.
And I believe you get various questions from many people. Do you get any specific questions from Korean people, or want to introduce one question that you get most?
Yeah. No, I mean, I think, say, the questions you've asked me are they're fairly typical, and maybe they get asked more often in Korea, right? I think a really common issue, which sometimes comes up as a question, is like service granularity, right? And I think there is a tendency for people to take the term microservice too literally and have lots of little services. I've worked with organizations where they have 300 developers, so they have 300 services, right? It's not, they don't have 300 services because they have 300 developers necessarily, though I've actually seen that as well, where it's like you have a team, and then each person on the team has their own And that to me is very much an anti-pattern, right? Like given that, you know, like sort of one of the goals, one of the dark energy forces is team autonomy. You just need one service for that team to be, you know, autonomous or be able to deploy their changes independently, right? You don't need lots of little services. And sometimes the way that comes out as a question is, we have lots of services, can you help us? But we're having problems testing them. Yeah, so if I was like, yeah, so this sort of goes, well, we have lots of services and we're having problems testing them. And then I go, well, how many services do you have? 5. How many developers do you have? 5. Why don't you just merge them all together? And it's like, oh yeah, you know, so you sort of solve the testing problem that way.
So did your customer who wanted its 300 microservices change their mind?
I don't know if they really did. They seemed happy. I just said that it just seemed like a lot.
Ah, okay. And
I mean, that company, I don't think they were specifically, they didn't feel like they had problems as a result, but at least in my mind, it just seemed unnecessary.
oh, okay. But if we have more services, that means there are many network communication through each other. That means it requires more. Its implementation is more harder. So,
Yeah. Well, you're right. I mean, this gets back in, so that we talked about the dark energy forces, right, which are reasons to split. And then there are the dark matter forces, which are reasons to not, right? And one of them is like, you want to have simple interactions between services so that you can understand them. And the more services you have, the greater the risk that some operations will be just too complicated to understand, right? And I've certainly read companies, there's a couple of examples of companies facing this problem, right? So imagine you have a long chain of calls, right? So service A calls B, that calls C, that calls D, that calls E. So service A is failing, right? So you look in the logs for A, and it's like, oh, A is failing because there's a problem with B. So you then ask team B to go investigate their service. They look in their logs, and it's like, oh, it's C, you know, so on and so forth. And and so you could imagine like the, should we say, JIRA issue, getting assigned to team A, and then they reassign it to team B, and then they, so on and so forth, right? And which on the one hand, maybe it's not so bad, but you think every time that ticket gets reassigned, there's a delay, right? Someone has to notice that they've been assigned a ticket, open it, look in a log, and so on. Meanwhile, A is down, right? And if that's absolutely mission critical, you need to actually fix it, you know, ASAP. But the more services that it depends upon, the longer it's going to take to actually troubleshoot it. There was this guy, Steve Yegge, Y-E-G-G-E, long time ago, 10 plus years, he wrote this rant about, I think it was like, he used to work at Amazon, and then he was kind of complaining about what was happening at Google. And one of the things he'd mentioned was this exact problem of having to basically reassign tickets. It was just taking longer the more distributed operations were. And then more recently, I saw an article where it was like Uber, which actually had a super fine-grained architecture. Maybe like 2,000 developers, 2,000 services kind of thing. And they were realizing that was impacting availability because of this sort of it's troubleshooting problem. And the article described how they were consolidating services in order to make them easier to debug. Anyway, so that was one reason for simple interactions, right, is ease of understanding and troubleshooting. There's also efficiency, right? You know, the more network hops you get, the more round trips, the more you're transferring over the network, the less efficient your system is. There's also, the more distributed it is, the less acid it is from a transactional point of view. Right? Like ideally an operation should be a single acid transaction inside one service, and if you distribute it, it's now eventually consistent, which is much more complex. And then you can also have problems around runtime coupling as well. You know, the more services that need to be up in order for an HTTP response to be sent back, the less available the system is. And remember that this was sort of wanted to tie back to a previous point. I did this review of sort of, well, kind of an e-commerce, a payment company, right? So I met with the team. They got requests from this large e-commerce company to sort of charge a payment. And the team that was responsible for handling payments had a couple of services. Didn't seem too bad. And then they said, oh, we just call the fraud service. And it was
fraud
like,
service?
Fraud, you know, fraud.
Detecting service?
Yeah, detecting fraud, right? And so it's like, okay, 3 services, didn't seem too bad. But then I go talk to the fraud service team, and there were like 4 people, each one of them had their own service. So suddenly we've got like, I've lost track, but 7 or 8 services involved on this sort of mission critical API that needed to be low latency and so on. And so that, you know, it's kind of a direct result of an excess. So they were, you know, there was a risk at that point. And that was a, you know, result of this excessively fine-grained architecture.
Yeah, thank you. And one of your mentions reminded me, like in 2015, when I take a class from you, I asked you about how about acid transaction? Like, can it be like replaced by compensational transaction or saga pattern? But actually, you told me that like that is how real world works. I think it was so. Yeah.
Oh, I might have said that, yeah.
Yeah.
Well, you know, I think at the time, the reason I said that was so, like in my first book, Pojo's in Action, which was basically, you're in the world of monoliths, I had this banking example, which was transferring money between bank accounts, right?
Oh, yeah.
And it was like, begin a transaction, debit one account, credit the other, commit the transaction. And then 5 years later, I gave a talk about microservices and the saga pattern, where it was like, where you have one transaction that debits the from account, another transaction that credits the to account, and then there's also, but then you might need a compensating transaction for the debit if let's say the to account was closed, right? And someone who worked for a bank said, oh, that's how we do it.
Ah, okay.
Because you could argue that in sort of real world application or complex IT systems at banks, you don't have one database, there's many. And so you actually need compensating transactions. And you could certainly say, yeah, if I like tried to send you money and I got your account number wrong, money would probably be debited out of my account, fail to be credited to yours, and then the bank would execute a compensating transaction to hopefully put the money back, right?
Yeah.
And then there's also a famous article which is kind of fun, which is like Starbucks does not use two-phase commit. So right, you go into a coffee shop, you pay,
Yeah.
right? They don't lock the door until you've picked up your coffee, right? You could actually pay and walk out.
Ah, right. Okay.
If you think about it,
right.
But if this was if you were to treat buying coffee as an ACID transaction, they would
okay.
not let you
Yeah.
leave until you've taken your coffee.
Ah, that's interesting.
Yeah. So anyway, it's like I think it is. Starbucks does not use two-phase commit. Is the article from a few years ago?
I think I should read about it. Yeah, read it. Yeah. Losing the ACID transaction is kind of most dreadful point that for people when they adopt microservices.
Well, I would look at it this way. So sagas have the potential to be complicated, but they are not always complicated. They can in fact be quite simple.
All right.
So for example, imagine you've got an order system, all right, an e-commerce application, and then you have a fulfillment system that's responsible for, customer orders a pair of shoes, order system sends a message to the fulfillment system saying, ship the shoes, right? That's a saga.
Oh, okay.
But it's a really simple one, right? It's basically one system notifying another that it needs to do something, right? You wouldn't even, you would just implement that without really thinking about it, right? But in reality, it's a saga.
I think Saga relieves many that worries of that transaction stuff, and the only thing that is I don't know how to say, but like when I work with people, like most of them are very good at writing SQL, but they are not used to writing business logic in application, in example Java. So like for a fixed period, there are some limited things they can learn in fixed time. So I always try to introduce them with something they are kind of accustomed to, they are good at. So my first approach is always like make just like small separate systems so that they don't have to communicate each other through API or event. If it is possible, I think that is better. That is best, because like they are.
Yeah. Well, the way I would express that, it's like you have a microservice architecture where all operations are local to a service, to some service, right? And you're absolutely right. That is the ideal.
But there are some systems that cannot make it that way. Like even though we split like into 3 or 4 services, those are needed. That business domain actually requires like semantic lock or compensation and transaction. So I think in that case, Saga really helps because we cannot, and that relieves the developers that effort to handling those transactions.
Yeah. Well, it's I mean, so if you have grouped the subdomains into services in a particular way, such that an operation that updates those subdomains is distributed across multiple services, then you basically have a choice. One is use a saga, right? and then you have to design it carefully. And fingers crossed it's simple or not too complex, right? But the other option is to actually change the service boundaries in order to make the implementation of that operation simpler. And this is sort of the job of the service designer or service architect, is to make these kinds of trade-offs, right? Because, you know, you have a choice between an operation that has a complex saga, or you have sort of larger services that perhaps then that don't address the dark energy forces quite as well. So it's like complex saga versus reduced team autonomy, maybe a slower build, and so on and so forth. So you have to pick kind of the least worst option, right? At least, I mean, it's hard to talk about in the abstract, but because you can only make this determination in in a concrete scenario.
Right.
I mean, there's all kinds of scary potential problems, but whether they actually are real depends upon what actual services you have and which particular operation you're talking about.
I think that is a very good point, because many things could be very dreadful, but if it doesn't happen, we don't have to worry about it.
Yeah, and you make trade-offs in terms of what your service boundaries to avoid the problems. And then, yeah, I mean, like one of the things I've been working on, which I'm super happy with, and that's what the service design workshop was about, right? Is this assemblage process. And so that is this process that, you know, it's like a five-step process for defining a service architecture. And it sort of provides the framework in which you're making these various trade-offs around service boundaries and operation design.
I think the assemblage that you introduced it like last year.
And I did not call it Assemblage. I did not come up with a name until Christmas, actually.
Oh, okay.
And it might have evolved a little. I mean, I've been iterating on it for a while now.
Oh, okay. So maybe I think recently when I always look up your seminar like, clips at YouTube, but assemblage could be on your next topic.
Yeah, I know. I need to talk about it more. Like I talk about it in workshops, but they're obviously private. I don't talk about it. I haven't talked about it enough in public. But basically, I mean, the way it works, and I can't remember if what the class you taught was the same, but it's like step one is to identify the system operations, right? So each operation is some behavior that can be invoked somehow, either by the user, by an external application, or by the passing of time. So that could be like create order, create customer, cancel order, find order history, right? That's step one. Step two is identify the subdomains, which are these slices of business functionality like order management, customer management, and so on, which implement, so the operations act upon business entities. The business entities are grouped into these subdomains. And so there's this sort of relationship, right? And then step three groups the subdomains to form services. And then if that results in operations being distributed across services, you then have to design the operation using one of the service collaboration patterns, like Saga, specifically if it's a command, you'd use the Saga pattern. If it's a query, you'd use API composition or CQRS. And sort of the way you do it actually is you rank the operations by descending importance, and then you take each operation in turn and then figure out a design for it, which means that operation acts upon subdomains A and B. Those subdomains need to be assigned to services, and maybe that's been done already, or maybe it hasn't, in which case there are many possible assignments. And then for each of those possible assignments, you think about a design for that operation, and you pick the best one, or you pick the least worst one, right? Because you do the trade-off analysis. And then you move to the next one in the list. So that's, and then the step 4 is you sort of do a global evaluation of your architecture. And then step 5 is you refactor it to eliminate any sort of architectural smells. So you sort of revisit the design decisions that you made for each individual operation and just kind of improve things.
I think I took your workshop class like last year's June.
Okay.
And I think it wasn't that formal then as much as you just described, but I think it became more formal.
I think I can't remember what it was like last year.
Okay. And if it is like it's not serious, but can GPT learn that process and perform it for people? Do you think that is possible, or maybe part of it?
So sick of talking about ChatGPT. It's funny, right? Like, I don't even know if you should call ChatGPT an AI, right? Because essentially what it is a text generation algorithm, right? Given this input, predict the next word. And I think sometimes it accidentally appears to be smart, right? But it struggles with facts. So I'm sure there will be some good, profitable use cases for it. I mean, I don't know if I'm not sure whether any have been actually identified yet. Especially the profitable part. But I think you look at developer-oriented AI tools like Copilot and their code generation, right? And yeah, sure. But I guess I'm skeptical. Like, if you think about, we're trying to define services, right? And which to me is more generally, it's all about identifying abstractions, right? Because I think if you take a step back, right, software design is all about grouping things together to form meaningful abstractions, right? Whether that's grouping fields and methods to form classes, classes to form packages, I guess packages to form subdomains, and then the next level above that is subdomains to form services, right? I guess I'm skeptical that ChatGPT is any good at identifying abstractions.
Oh, okay, got it.
I think you need a truly intelligent human being to do that.
Yeah.
I mean, I might be wrong, right? But it's just like ChatGPT is not that it's not smart. It's not intelligent. It doesn't know anything.
And yeah, I think so. And
I mean, it's funny. I saw this article about ChatGPT, and he described it. It was actually an emergency room doctor, and he described ChatGPT as an intern who was often hungover.
Hungover.
Had too much alcohol the night before. And so sometimes it did good work, but quite often not so much, right?
Not reliable too. Reliable, yeah.
And he actually used ChatGPT not for diagnosis because he thought it was not very good at that, but for actually generating explanations to give to patients' families. So they could so it would actually explain what was happening in sort of compassionate, non-technical terms. And I thought that was a really good kind of use case. So I think about if you think about ChatGPT as being an intern developer, right, like a junior developer, I would argue one huge difference between junior developers and experienced developers is their ability to identify abstractions, right? I feel like when I've worked with junior developers, they just copy-paste code, right?
Were you?
Once I was. I still copy, but I've seen like code written by junior developers and they copy-paste, right? And I look at it and it's like, you need abstractions, right? Which might be simply extracting a method and putting the common code into a method, right? Or higher level things like, we need a new class here, right? And to me, that's what good design is about. And I think junior developers struggle with that.
So they need to it requires experience to get that ability.
Yeah. And so if you think about ChatGPT as a junior developer, right, they will just generate lots and lots of code, and maybe it's right? You got to debug it, but I think it won't have good abstractions. But I could be wrong.
Yeah, but I kind of agree with you. Yeah.
But I know everyone's talking about ChatGPT, right?
I noticed ChatGPT like a few months ago, but everyone talks about. So I think it is very. You published your book in 2018. What would you add or update if you prepare a second edition?
Yeah. It's an interesting question. I think one good thing about my book is that even though it's, 5 years old, right, roughly, and if you think about it, some parts of the book were written in 2016, right? Yeah. So there's, 7 years. I think it's all still very relevant. The core concepts, the core patterns. Right. And to a certain extent, even the technologies that it talks about are still very relevant, right? I guess, I was thinking about this, probably I would, add a chapter on Kubernetes.
Oh.
I think if you went back, around the time I was writing the book, Kubernetes was was still emerging. I can't quite remember what things exactly when Kubernetes sort of really took off, right? Maybe by 2018 it had, but I think there's this very solid Kubernetes ecosystem today, right? I've been doing a bunch of stuff with Helm charts, and then Flux CD for continuous deployment, and Flagger for doing Canary releases. So there's some really, really interesting open source projects around that. So I could imagine having a chapter on that. And then the other thing, sort of low-level technology that I'm excited about, or actually that's an exaggeration, but I like it, is test containers, right?
Test containers.
Yes.
Oh.
So like I think, so imagine you write a test, right? And for say one part of your service and it needs a database and a message broker. It's really great to actually just use Docker for that. Right? And so before, like I've been doing this for a really long time, is I'd use a plugin for Gradle that would actually start a bunch of containers, that would actually, well, it would be the Docker Compose plugin for Gradle that would launch the database, MySQL say, and Kafka, Zookeeper, and then run the tests. And so, you know, I didn't have to worry about installing anything. But now there's test containers, which is basically a Java framework. So your JUnit tests can easily launch the containers that they need. I think that's really quite powerful.
Okay. Oh, I didn't know that. I think I should read.
Yeah. Well, part of it, I mean, one of the really interesting things is that like Docker is incredibly useful, right? Because, you know, rather than every developer having to install, you know, the database, the message broker, whatever else they need on their machine locally, you install Docker, and then everything else is trivial to install, right? It's basically Docker run. The problem you have is in an enterprise environment, security people don't like that because they can easily run stuff on their laptops, right? I mean, I think the solution is to have a secure Docker infrastructure so you can only run approved images. But because I know a lot of enterprises, they block this, whereas for me, it's just fantastic, right? But anyway, that makes testing kind of means that your JUnit-based integration tests can just provision the containers that they need, and that's super useful. But anyway, those are sort of minor things, because you know the essence of the microservice architecture is defining services, right? So like the new version of the book, I think dark energy and dark matter would feature throughout, because those forces end up playing a kind of like things you need to consider in quite a few of the patterns, Saga or API composition and so on. And then also Assemblage, the architecture definition process, rather than just being a few pages in chapter 2, will most likely be an entire chapter of the book.
Oh, okay.
Because there's a lot to talk about there. And maybe, I don't know, what would I drop? I'm less interested in event sourcing. You know, if you asked me in 2016, I would have said it's microservices plus choreography-based sagas powered by event sourcing is the one true way to implement microservices.
I mean, replacing that ACID transaction or things like that.
Yeah, exactly. But then I realized that you can just publish events by calling like domain event publisher.publish. You do not need to use event sourcing. You can just use your regular persistence framework. So that's a big simplification. So it's, to me, it's no longer an integral. I mean, it's sort of this sort of shift in view occurred while I was writing the book. But in the beginning, that was how you did microservices. But by the end of the book, it was like, not so much. So I might even drop the event sourcing chapter just because it's like not that. It has its use cases, but it's not central to the microservice architecture. Maybe instead of a chapter, it will just become a section of like how to do business logic, you know? Things like that.
I can't wait that. Like if you start it and when MIP program started, please announce that. I will follow that.
Well, I'm seriously thinking about it.
Oh, okay, that is very good news.
Yeah, and so yeah, I guess I should do something. I know I've sold at least one copy.
Yeah. Just at least 2 copies, like, because it is me program.
Yeah.
Yeah. Oh, it's gonna be interesting. Yeah. I think it is time to wrap up. I didn't know we spent this time.
Time flies when you're having fun.
Yeah. Having fun with you.
Can we go have beer and pizza now?
Yeah, that's good. Great. And let's wrap it up. And it was a really good time for me, and I can't wait to see you again here.
Oh yeah. Well, I must say we didn't get into this, but I'm excited that your book came out earlier.
Thank
I
you.
mean, it's in Korean, but I just know that it's got a lot of really valuable content based on your experiences with real projects. So I would encourage everyone to read it.
Thank you. And actually, I could write my book because at first time I learned it well. From you, because you told me what is microservices and what it is for. I could make good decisions through my career, so that those good decisions became content of my book.
Oh, great.
So I could write it because of you.
Oh,
thank you.
Thank you. That's awesome.
Do you have any advice or say something to something essays or developers, especially about with Microsoft's architecture?
Well, yeah. I mean, I think, I mean, it's really hard to sort of summarize a complex topic in just one short phrase, right? But I really think that, whenever you're making design decisions, right, which is basically what software development is all about, is that it's important to remember that it depends. The answer to any design problem, like, should I use a microservice to do this, or should I use the microservice architecture, is it depends, right? That's like the first step towards enlightenment, right? Then the second step is also to then understand the criteria that dictate what a good solution looks like. So in the case of, like, say, a lot of the microservice architecture, the criteria are basically the dark energy, dark matter forces. But in general, for any given design decision in any realm, there are a set of criteria. And so as a designer, you need to actually think about what are the criteria that are relevant. And that actually depends upon the specifics of your application. So I think those are really 2 important points. And then the last point, which I actually really want to blog about, and I saw this tweet, and it was something along the lines of, you're in the best position to make design choices for your application. No one on Twitter can make decisions for you, right? So it's actually on, speaking to a developer, it's on you to make the best decisions for your project. So just because some famous person says this is good, this is bad, they do not understand your context, the situation, your application requirements, and they might be biased. So I think that's another, something else to keep in mind.
But I think many people should listen to what you just said before.
But you might be biased. Well, what I try and do is, I mean, like, my whole, if you were to summarize everything I say, it's like, It depends.
Yeah,
Right? That's the one universal truth. Right?
that is truth. Yeah.
Hopefully it is true.
Oh, yeah. 지금까지 긴 시간 그 이야기 들으시냐고 수고하셨고요. 다음에도 더 좋은 자리를 마련해서 좋은 얘기를 들려드릴 수 있었으면 좋겠습니다. 감사합니다.